Good morning, everybody, and welcome to today's math lesson. This morning, we're going to be looking at 8.2, using variables to write pattern rules. I've already uploaded the lesson from Edwin onto Google Classroom, so if you want to follow along, you're more than welcome to. Today's learning goal is using numbers and variables to represent mathematical relationships. So if you saw yesterday, I uploaded our 3 learning goals for this unit on algebra, and that's our first one, using numbers and variables. So we have this problem here. We have this pattern, the first 3 figures of this pattern that uses what are supposed to be blue rhombuses from the patterning blocks, but I didn't bring any rhombuses home, so I had to freehand them, but that's okay. So we can see figure 1, figure 2, figure 3. Now looking at the 3 figures, it looks like the 2 rhombuses at the bottom, these guys here, they're always the same. They're always there every single time. 2 there, 2 there, 2 there. And the one on top seems to be increasing by 1. So we have 1 there, 2 there, and 3 there. So if I put that into a T-chart to help me visualize it, sorry guys, I'm just getting used to doing this. We have figure number 1, figure 2, figure 3, and the number of blue blocks has 3. There's 3 blue blocks in the first figure, 4 blue blocks in the second one, and 5 blue blocks in the third one. So if I were to continue the pattern going on, if I were to imagine drawing figure 4 and figure 5, so that means in figure 4, there would be 6 blocks, and in figure 5, there would be 7 blocks. So we look at the number of blue blocks and we look at the pattern. Well, it's increasing by 1, 3, 4, 5, 6, 7. But what if I were to try to figure out what's the pattern rule using the figure number and the number of blue blocks? So in other words, how do I get from 1 to 3? How do I get from 2 to 4? How do I get from 3 to 5? Well, from 1 to 3, I would add 2. From 2 to 4, I would also add 2. 3 to 5, I would also add 2. 4 to 6, I would add 2. And from 5 to 7, I would add 2. Oh, I don't know why I wrote 5. I would add 2. Now, if we go back to our design, that add 2 represents the 2 at the bottom because those 2 are always going to be there. Those 2 never change. They're always part of the figure design. So that plus 2 is for these 2 blocks right here. So the 1 block plus the 2 blocks gives me the 3 blocks. So the figure number always represents the blocks that are at the top of our design. The what we're adding represents the blocks at the bottom. So if we write that as an equation, we can say that the figure number plus 2 will always give us the number of blue blocks. All right? Now, what if we were to try to figure out if we were to use this equation remember it's an equation because it has an equal sign. What if we wanted to use that to find out how many would be in the 5th design or the 5th figure? So I would rewrite my equation, figure number plus 2 equals the number of blue blocks. And remember the 2 is what we call the constant. It's called a constant because it never changes. It's always there. If I go back to our designs, these 2 blocks at the bottom, these two, they're always going to be there. They never change. So it's the constant. So all I have to do is take out the word figure number, put in whatever figure number I'm trying to find for, add my 2, which would give us 7 blue blocks. Okay? So a couple of reminders. A variable is a letter or a symbol that represents a number. So just trying to find a good angle here. Okay, that seems to work. Now, the beauty with variables is that they don't have to be letters. They can be anything. If you want to use a smiley face, I know in your homework from 2 days ago, instead of a letter, they had a blank box. They just had a white box. That can be a variable. It's just something that takes the place of a number. All right? And remember that we can use an algebraic expression. So algebraic just means algebra. Expression is an expression. Remember, an expression has no equal sign that has numbers and letters. So if you ever come across a number sentence that doesn't have an equal sign, but it has numbers and letters in it, that's an algebraic expression. So for example, it's really hard when you keep seeing the shadow of my big head. So for example, figure number plus 2, or f plus 2, is an expression. Why f? F stands for figure number. Really, you can use any letter you want as a variable. You can use P, Z, B, pick something. I just pick F, F for figure. If I wanted to do a smiley face, if I wanted to draw a picture of a cat, it really doesn't matter. Just as long as you remember what that symbol represents. Now, if I were to rewrite the figure number plus 2 equals the number of blocks, then I could rewrite that as F plus 2 equals B, B for blocks. That would be an equation. Why would it be an equation? Because there's an equal sign. No equal sign, expression, equal sign, equation. Easy enough to remember. Just look for the equal sign, okay? As a reminder, if you ever see, which you probably will, you can see that shadow, can't you? All right, let's try it like this. Okay. If you ever see a number right beside a letter and there's no sign in between them, like there's no, if you say something like this, like 4n, that means multiplication. So if you ever see a letter and a number right beside each other, that's the same thing as 4 times n. And I know in your homework for today, there's a couple of these where it's just a letter and a number right beside each other. That just means multiplication. Just multiply the two of them together, okay? Let's look at another example. I have these 3 figures here. Figure 1 looks like this. Figure 2 looks like this. Figure 3 looks like this, all right? And I've made a T-chart to help me count the number of blocks. So figure 1 has 4 blocks. 1, 2, 3, 4. Figure 2 has 5 blocks. 1, 2, 3, 4, 5. And figure 3 has 6 blocks. 1, 2, 3, 4, 5, 6. So how do I get, if I wanted to figure out what's the rule, what's the pattern rule that I can use to help me find any number of blocks? Just going to change my marker here so I'm not writing everything in red. Okay. Let's go with green. Jeez. Okay, so how do I get... Now, if I look, the pattern going down, 4, 5, 6, it's increasing by 1, which is great. Nothing wrong with that. Problem is, add 1 every time doesn't tell me how to find out for any figure number. So I always have to go across the chart. How do I get from 1 to 4? How do I get from 2 to 5? How do I get from 3 to 6? Well, I add 3. 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. And where does that 3 come from in relation to our picture? Well, the 3 represents the 2 squares and the trapezoid. Because if you look at the 3 figures, those 2 squares and that trapezoid are always there. They never change. I don't add any new trapezoids. I don't add any new squares. The only thing that's increasing is actually the number of triangles. All right? And it goes from 1 triangle, 2 triangle, 2 triangles, 3 triangles, 3 triangles. And how do I write this as an algebraic equation? I can say that the figure number plus 3, remember 3 is the 2 squares and the trapezoid, that's 3 blocks, will always give me the total number of blocks. If I want to write that as an expression, I could say f plus 3, and 3 is the constant. It never changes. It's always going to be plus 3. In this case, it's always going to be plus 3. So, what if I wanted to find out the number of blocks in the 7th figure? Well, all I would have to do is take my algebraic expression. Remember, it's an expression because it doesn't have an equal sign. F plus 3. Take out the F and put in the 7, and then just do 7 plus 3. So, 10 blocks. What if I wanted to find out for the 12th figure? My expression, F plus 3. Take out the F, put in the 12. 12 plus 3, 15 blocks. What if I wanted to find out for the 40th figure? See, when we get into these big numbers, the 40th figure, the 100th figure, that's why we just can't go add 1 every time, because then we would be adding 1 every time, and that takes way too long. if we use an expression with a variable, in this case f, and f is our variable because it can be any number. Over here, f was 7. Over here, f was 12. Now over here, f is going to be 40. That's why it varies, it changes. Then we just do 40 plus 3. 40 plus 3 is 43 blocks. What if I wanted to find out for the 99th figure? Simple. Use my expression, f plus 3. Take out the f and put in 99. 99 plus 3, 102 blocks. Okay? So algebraic expressions are really beneficial and really helpful for us to find out a pattern for, I just gotta flip the paper here, to help us find out the pattern for a larger number. So if we need to find out for a bigger figure, we can use the expression to help us do that quickly, because then it just becomes multiplication, or in some cases addition, or in some cases subtraction. So I know I've said this before. In previous grades, we would have just gone down the chart, find out what the common difference is, and just use that. Oh, 1, 1, 1. Great, it's going up by 1. Wonderful. Now now that we're intermediates, we have to go across the chart. How can I use this information to help me get this information? Okay, so watch the video as many times as you need to. Homework will be posted, and I'll indicate which numbers I want you to do. All right, have a good day, everybody. Bye-bye.